Okay, good evening, ladies and gentlemen, and welcome to this Saturday evening session on Lean Six Sigma, where we go deeper into the concepts. And just click on OK there, please, and settle this up. Okay, superb. And so today we are going to go deeper into the concept of non-parametric testing. So what is non-parametric testing and where does it applied, etc., etc. we'll discuss. But before that, I have very interesting announcements, and the announcements are of the successful people this week who have completed their green belt and black belt certification. Let me announce the names for you, and then we will all congratulate them in the chat. Okay, so for the green belt we have Kritika Joshi, congratulations, you have completed your green belt. Aman Sain, you have completed your green belt, congratulations. And Mr. Dharmaraj, congratulations to all these three participants. You have completed your green belt certification successfully this week. And apart from that, we have 4 participants who have completed black belt certification as well. Mr. Arvind Ghadge, congratulations. Mr. Mohan Durai, congratulations. Joel Praveen, congratulations. And Naveen Kumar, congratulations. So the 4 participants we have, successful black belt certified people. And you guys can give your green belt, black belt certifications according to your, preferred time and date. So let me also type congratulations as well. I request everybody to do the same. Yes, super, congrats. And the one more objective of announcing the name is to motivate you people as well. Okay, I always suggest this whenever we start the journey. Okay, you should basically start to complete, aim to complete it within 60 days. That is what the challenge is. Okay, so let's say you start on 28th of February. Let's finish by April end. Okay, because when your enthusiasm is at the peak, that is the time. See, and certification is the beginning of the journey and not the end of the journey. So remember these words. Certification is always a beginning and not the end. Okay, so with this, see, in our Monday session, so we have Monday session as well as Saturday session. So what we do, Monday session we cover a little bit of basics, green belt stuff, etc. And Saturday sessions we go a little deeper into the black belt content. Okay, so today's topic is into the black belt content part. For the very new members, it can be a little difficult, but my recommendation is sit with the open mind, because anyways you are going to face this within your green belt and black belt journey, right? So everybody is on a different phase of the journey, so it doesn't matter, but it will come, all the dots will get connected eventually. Okay, so today's topic is non-parametric test. Okay, so what is non-parametric test? Non-parametric test is nothing. Let me share my screen right now, my whiteboard. Let me just give some background about what is this non-parametric test. Anybody is aware of non-parametric test? Just type yes in the chat box. And what is that? If you are aware of, just type yes that you are aware of non-parametric test. And what are those? What does it mean? Yes, anybody? No? Okay. Okay, you're not. Very good, very good. Doesn't matter. Very nice. Superb. Superb, superb. Okay, so let's cover with the basics. Okay, now so we have in the define, measure, analyze, improve and control. Okay, these are the 5 phases in which entire our problem solving of DMAC goes. Now in define phase we define what is our project. In measure phase we collect the data. We identify the patterns and the trends of the data. We do the process capability analysis in the measure phase. Then we go to the analysis phase. In analyze phase we find out the causes and the root causes, right? Fishbone and root cause analysis we all know. Once the root causes are done, we actually validate those root causes. What do you mean by validation of the root causes? That means, for example, my you know, let's say one of the root causes, let's say, let me give you example. Root cause is a lack of experience. Okay, now lack of experience in the workforce is one of the root cause, because of which the defects are coming, because of which the customer complaints are coming, etc., etc. Now that is your root cause. Now you have to actually prove that there is a connection between experience and the defect. How will you do that? So what will you do? You will collect some data of experience, you know, the workforce experience, and vis-a-vis you collect the data of what kind of impact it is making on the on your output, which is, let's say, defect. Now there are a lot of things which you can do. You can do correlation, you can do regression. Okay. Now by doing this, you are basically validating this root cause with the data. Are you understanding? So all the root causes are based on our experiences and knowledge, our domain expertise, our knowledge, our hunches, our opinions. That's what we find out our causes and the root causes. But what statistics says, do not assume anything. You have to basically validate each and every point with the help of data. Okay, especially the root causes on which you are going to find out the solution. You have to be doubly sure that these root causes are the real root causes and not only your opinions. In one of the case, we found that when we put experience on the x-axis and a defect on the y-axis, we found no correlation like this. That means what assumption these people were having was not statistically proven. Their hypothesis was not statistically proven. Are you understanding? So this is called as root cause validation. Are you clear with the concept? Just give me yes in the chat box. Are you clear with the concept? What does validation mean? All the root causes have to be validated with the data. Are you clear? It is just like when the policemen nab few people, right, as the thieves, etc. They have to provide the evidences. If the evidence is not there, then court will say they are not guilty. Similarly, this is that process of giving the evidences. If evidence is not there, then this root cause does not hold right. Okay, so we have to reject that root cause. Okay, now to do this, we have a very important factor which is called as hypothesis testing. In the green belt also we have hypothesis. So regression, whatever this part what I've done, this also is one part of the hypothesis testing only. Hypothesis meaning your opinion, your assumption, and we are testing the assumption with the help of data. That is called testing your hypothesis. Now in hypothesis testing, there are various factors basically we do. Okay, in the green belt level also we do the hypothesis testing. So in a nutshell, what we do in the hypothesis testing in the green belt level, we collect the data. Okay, for example, let's say I want to find out who is the better let's say who is the better supplier. Okay, who is delivering faster. So what I will do, I will collect the data of supplier A, let's say the supply time data. Okay, average delivery time, let's say. So it will be the average is XA, which is supplier A, XA bar. X bar is the average side, right? And there is another supplier X bar B. So these are the two suppliers. I will take average. I will feed the data in the software Minitab, and Minitab will test the hypothesis whether there any difference in these two suppliers. Okay. Now there is a slight conceptual understanding we have to do. Okay. There is something called mathematics and there is something called statistics or probability. Try to understand the difference between these two. Mathematics is what? let's say if I collect the data of supplier A and collect the data of supplier B, let's say for example here, supplier A supplies on an average 10.2 days and supplier B delivers in 11 days. So I have just taken the average, okay? Sometime 8 days, 9 days, 15 days, etc. I have taken the average, let's say 10.1 and supplier B is 11. Now, mathematically there is a difference of 0.8. Understand this? Mathematically there is a difference of 0.8. But hypothesis testing is not mathematical concept, it's a statistical concept. Statistical concept is all about the probability. If with the given sample data, if the difference is 0.8 days, will this difference be significant for the long term? Will this difference will be statistically significant for the population? That is what the hypothesis testing is doing. Are you understanding this? So the difference is there, mathematical difference is there, but we are not checking the mathematical difference. We are checking whether the difference which is mathematical of 0.8, is this different statistically significant for the long term? And this is what hypothesis testing basically does. So they give us, so the testing gives us a value called p-value. And if the p-value is less than 0.05, okay, we take certain decision, which I will explain you. Just a second. Okay. Now, first the concept we need to understand is this. Have you understood the difference between mathematical difference, which we are not testing here? We are testing the statistical difference, which is a probability difference, okay, which is generated by p-value. Are you conceptually trying to understand this? Just give me yes in the chat box. Mathematically, just simple. 11 minus 10.2 is 0.8. That is the mathematical difference. But with this sample difference, is it long term making impact on the population? Population is the overall data for a long term. That is what the probability we are testing, and that is what the hypothesis testing is all about. Yes, clear? Now we all have seen the data of what you can say, sample and the population. Okay, yeah, I will explain it to you once again. Very good. See, this is what I like. Okay, if you do not understand, right? If 9 people are saying yes and you are the only one remaining, please do not hesitate to say that I have not understood what you are talking about here. Okay, really, because this is where we will go very slow. I want you guys to understand the concept very easily. Okay, yes. So because it's an advanced concept, right? So I will just cover the hypothesis testing quickly, a little bit in details, and then we will go to the advanced concept, which is the today's topic. Okay, so let me just quickly go to. So there are two types of hypothesis here. Let me go a little into the basics. So hypothesis meaning assumption, and testing your assumption with data is what the hypothesis testing is all about. So there are two hypotheses. One is called null hypothesis, okay, which is denoted by HO, which is called statement of equality. Just make a note of this, then I will explain so that you will understand it better. Okay. The second one is called alternate hypothesis, which is denoted by HA, A for alternate, H for hypothesis. Okay, which is nothing but statement of difference. Now these are standard what you can say definitions. Okay, now let's take the same example of vendor A and vendor B. So null hypothesis will say, HO will say XA bar is equal to XB bar, and alternate hypothesis will be exactly opposite statement. It will say XA bar is not equal to XB bar. So the average of the first vendor is not equal to the average of the second vendor. Okay, X bar is the average. Now we will collect the data. Now here what we have to realize is the population and the sample theory, right? So here is the population, which is the long-term data, and sample, which is the short-term data, which is a representative of the population. On the basis of the representative, basically we are testing, because we cannot analyze all the data all the time because of the resources, time, etc. Right? So we are taking the sample. On the basis of the sample, we are checking the probability about the population. For example, in the cricket match, which I give this example very regularly, in the cricket match, let's say 5 overs, 40 runs, 2 wickets is the sample data, and the projected score is the population projection of the 20 over. Are you clear with this? Just give me yes in the chat box. So sample meaning a short term data, and population meaning the long term, which covers the entire universe of that space. All right, everybody with me? Yeah. Yeah, Manivandan, are you clear till now? Are you with me? Just give me yes, quick yes in the chat box, so that we'll go step by step. I'm just going a little step back. Yeah, very good, very good. So null hypothesis, statement of equality in difference, what you can say, the alternate hypothesis, statement of, okay, difference, okay, very good. Yeah, no problem, Padmanabhaji. We are just talking about basics of hypothesis. So again, I want to choose between 2 wicket keepers, Rishabh Pant and KL Rahul. Okay, so one. Let's say I will take the batting average of Rishabh Pant, batting average of KL Rahul. So average of Rishabh Pant is equal to average of KL Rahul. That is a statement of equality. And average of Rishabh Pant is not equal to average of KL Rahul. That is the statement of difference, which is alternate hypothesis. Now we will collect the data. Let's say Rishabh Pant will say, so this is X bar Pant. That's, let's say Rishabh Pant's batting average is, let's say 42, and KL Rahul's batting average is, this is X bar Rahul, which is, let's say 43. So only 1 run average difference. Okay, now mathematically there is a 1 run difference in the averages of these 2 players, but is this average statistically significant for the population? That is what we want to check. Okay, now if I have to draw this just for your understanding, okay, so I will just take this data of let's say Rishabh Pant, and this is, let's say 42 average, and KL Rahul's, this will be, let's say 43. Okay, now if these are the distribution of the data, both datas, okay, both will be equal kind of mean, mode, median. Now you can see, if imagine just for your what you can say, visualization, visualize this. Imagine the area under this curve, total area, right from this entire area. Let's say imagine it is 100% area, okay, out of which this overlapping area is there, right, where the 2 distributions overlap. Okay, now this overlapping area is nothing but the p-value. Okay, if this overlapping area, now let's look at this. If these are 2 distributions, this is, let's say Rishabh Pant and this is KL Rahul. If they are very close, the overlapping area will be very high. If they have a difference, let's say KL Rahul is average is 50 runs, and Rishabh Pant is 42, KL Rahul is 50. So their difference will be very high and overlapping area will be low. Are you understanding this? If they are close, they will be overlapping. If they are equal, they will overlap 100%. So p-value will be 100%. If there is a difference, the p-value will reduce. As they go differ, as you know, the difference increases, the p-value reduces. The moment, understand this, the moment the p-value reduces up to 5%, after 5%, statistics declares that the difference has become statistically significant. So overlapping area represents the p-value. That's what I'm saying. These are the distributions. If I draw the distributions, the overlapping area is distribution. See, this entire calculation of process capability, hypothesis testing, p-values, everything is done on one theory, which is the area under normal distribution curve. Are you understanding? So they just calculate this normal distribution curve. Out of 100%, if it goes less than 5% overlap, that means there is a statistical significant difference has happened in the means of these two distributions. Are you clear with this? Just give me yes in the chat box. P is the probability. P stands for probability. Are you clear? Yes. Graphically, can you imagine this? Two distributions with each other. Correct? Got it? Very good. Very good. So what we do in real life, what we do, we collect the data and we put the data in the Minitab software, and it checks whether there is a statistical significant difference. If no, it says there is a that the difference is significance. Okay, so how do you remember this? Okay, very simple rhyming. Write this down. P low, null go. Everybody write this down and type in a chat box as well, because this is where the entire hypothesis testing is summarized. P low, null go. That means whenever p value is less than 0.05, which is nothing but 5%, okay, you reject null hypothesis. Reject null hypothesis meaning you have to reject this statement of equality and you have to say that there is a statistical significant difference between the two distributions. Are you clear with this? P low, null go. Remember this rhyme and that will solve your problem. Clear? Super, super, very nice. So this is what no, this is not sigma 1, sigma 2. No, sigma 1, sigma 2 will come in the process capability standard deviation. Okay, this is hypothesis testing. Yahan tak everybody is clear? Just give me yes in the chat box. Let's open Minitab software. We will do a practical exercise of this. Okay, open any Minitab software. Minitab, Minitab this one. Yeah, Tarak Naji will do it. We'll do it practically, and chalo practically karte hain. Just open your Minitab. We'll do this practically. We'll create some data and do this practically. Okay. Or let me see if I can pull out some data for you. Everybody, if you have the laptop with Minitab installed, please open that quickly. Meanwhile, let me find out if I can pull out some data for you. All right, here we go. Okay, let me see if yeah, I can share this file with you. Just a second. Okay, so this is called 2 sample t-test. Let's open this file just for your understanding. Let me also open meanwhile. Just open this file which I've shared in the chat, and this will be this I will share in the masterclass archive as well. Okay. Super. Once you have opened, please let me know. It says 2 sample t-test. Okay. Yeah, opened. Everybody, just give me a quick yes. Yeah, even if you don't have laptop with you, you're traveling, etc. It's okay. Just observe what we are doing. Okay. Now there are 2 processes here. Imagine it is Gail Rahul and Rishabh Pant data. Imagine. Okay. So imagine there are 2 data points we have. Now how do we do the 2 sample t-test? So right now there is a standard process and a pilot process. Okay. Yeah, Tarak Naji, this will be a very good example for you to understand. Now standard process and the pilot process. There are 2 processes here. Now what we are saying, null hypothesis says, as usual, it is called statement of equality. It says both the process. So null hypothesis says x bar standard is equal to x bar pilot. Okay. And alternate hypothesis will say x bar standard is not equal to x bar pilot. Now let's put them into the test of hypothesis. So it will take the average of it. It will compare again the overlapping area, and the p-value will be calculated by the software. So we don't have to do it anyway. Software is doing it for you. So stat, basic statistics, two sample t-test. Just follow this path, please. Stat, basic statistics, and two sample t-test. Okay, when you are comparing two samples with each other, that is where we use two sample t-test. Okay, yeah, stat, basic statistics, two sample t-test. Done. So just check that out. This window will appear now. You have to select. Both samples are in one column. Here we have to select each sample in its own column because both have different columns, right? Right? If they have only one column, right, one below each other, so we would have selected the first option. But they have two distinct columns, so we have selected the second option. In the sample 1, select standard process. Sample 2, select pilot process, and click on OK. And we will see the p-value, which is 0.485. Okay, now just have a look at this. So standard process, you can see here, standard process mean, so x bar standard is equal to 14.65 and x bar pilot is equal to 14.34. So not much difference. Okay, but again we put that into the software just to check. Mathematical difference is very low. So is it what you can say statistical significant difference? So we just put that, and the overlapping area came to 0.485, meaning 48.5% of area out of 100% is overlapping, which is very high probability, p-value. So we are saying there is no statistical significant difference between these two means. Okay, x bar standard and x bar pilot, there is no statistical significant difference. If this is distinct and the area would be less than 5%, then we would have seen this is a statistically significant difference. Are you clear with this? Just give me a yes in the chat box. So this is how the hypothesis testing is conducted. Clear? All the new members as well, very simple. Yes, now we have just created this. Okay, so this is the basic stuff which is there in the green belt level as well. Okay, now let's go to the hat. Is what is hat? Meaning pilot process, right? Standard process and pilot process, meaning example, let's say there was one process which was which was original. Let's say standard is the old process, and the pilot meaning some improvement you have done. Okay, and you have reduced the average. Okay, very good, very nice. Yes, Mr. Padmanabhan, you are absolutely right. Imagine a scenario. The left one is the old process, and the team has said that now we want to reduce the lead time of this. Okay, so they have done the project, and the pilot process they have run, and this is the report of the pilot process. Now the average they want to compare, and they want to see the average must have reduced, right? There is a statistical significant difference. But when they do the two sample t-test, they observe that there is a slight difference, but that difference is not significant enough. It's a very small difference which is insignificant. That's what this test is saying. Are you clear? So means there is no significant improvement they have achieved yet. They have to still work on the project. Clear with this? Just give me yes in the chat box. Superb. Now let me share. Now I'm entering to the topic of the day. Okay, so the day's topic is non-parametric test. Okay, this I will share this Minitab file. I will share this PowerPoint presentation with you. This entire recording will be there. Everything will be there in the masterclass archive. Okay, yes, very good. So here is the non-parametric. What is non-parametric test? Let's understand this. So in statistics generally, everybody knows mean, mode, median, right? Just give me yes in the chat box. Mean, mode, median, everybody understands. Mean is the simple average. Yes. Mode is the maximum occurring value, and median meaning the central value. If I arrange the data set in the ascending or descending order, the central value is the median. Correct? In the normal distribution, mean, mode, median are very close to each other and they are in the center. But if there is a difference between mean, mode, median, it becomes a skewed distribution. Let me draw a little bit of that. So normal distribution looks like this, which is the basic distribution which we follow. Okay, but there are distributions like this. For example, this is called a skewed distribution, where mean, mode, median are different than each other. Okay, so if this kind of data comes, then what kinds of hypothesis testing has to be done, and that is called as what you can say non-parametric testing. Okay, so here you can see, when do we use non-parametric test? When the data is strongly non-normal. Okay, now in the black belt level, we have, whenever we come across non-normal data, in the black belt level we teach a concept of something called transformation. Okay, transformation, where we cover Box-Cox transformation. Okay, in which there are multiple types of transformations are there, right? Like inverse transformation, log transformation, etc. There is another strategy which is called Johnson transformation. Okay, so transformation meaning the shape changing of the distribution from non-normal, from the skewed distribution to the normal distribution. Okay, but if sometimes even after transformation also there is a resistance for transformation, that data does not completely get transformed and it remains non-normal, that is also possible. In that case, okay, you can use these kinds of hypothesis testing, and when the sample size is small, it is not generally. Now, how many data points we should have to get the normal distribution? Just type that number if you are aware of that number. Type in the chat box. Very good, very good. So 30 and above. Okay, so when you get 30 and more than 30 data points, okay, generally natural tendency of the data is to showcase the normal distribution, and you will see any data you take, normally you will see that kind of a trend. Okay, but whenever you don't have that kind of data, if the sample size is small, then you may get a little bit of skewed data distribution. Okay, in that case, you can use this non-normal, non-parametric testing. Okay, now this is, just take a screenshot of this. Okay, resistance of transformation meaning, for example, sometimes what happens, see, the skewness is very high. Okay, if the skewness is very high, now you do or let's say this kind of a skewness, and you have got long amount of data at one end, right? After even you do Box-Cox transformation or Johnson transformation, the p-value is less than 0.05 only of the Anderson-Darling normality test, right? So when that kind of situation, and it happens, a lot of time it happens, okay? Sometimes the skewness of the data is very high. In that case, even after the Johnson transformation or Box-Cox transformation, we get skewed data only. In that case, we basically use non-parametric test. Okay. Now, just take a screenshot of this. Of course, I'll be sharing this entire presentation with you. Now, in the green belt and black belt level, generally green belt level, we have covered one sample t-test, two sample t-test. In the black belt level, we have covered additionally pair t-test, ANOVA as well. Okay. Now, these are, so parametric meaning whenever you have normal data, normal distribution, okay, you get parametric test. Whenever you have skewed distribution, which is like this, okay, data, so you can get exactly similar kind of the test. Okay, let's say for example, one sample t-test. When do we use one sample t-test? When one data set want to be what you can say compared with the standard. Example, let's say the Indian cricket team decides that every batsman should have average of 40 runs. So that's a standard. Now every batsman's average will be compared with 40 runs. Okay, so that is called one sample t test. Then there is something called one sample z test. Now if you have less than 30 data points, you go for one sample t test. Okay, if you have more than 30 data points, you get normal distribution. See, z is nothing but normal distribution. Normal distribution is also called as z or z distribution. Okay, now one sample z test meaning whenever you have sample more than 30 data points. Okay, now on the other side you can see somebody, okay, I think by mistake got unmuted. Okay, so yeah, so I was talking about these are on the other side non-parametric test. When we have one sample t test, on the other side if the data is non-normal, you can have one sample sign test. Okay, if you have one sample z test when we have the more than 30 data points, then on the non-parametric side you have one sample Wilcoxon test. Okay, then pair t test we have again a Wilcoxon test, two sample t test ke man Whitney, etc, etc, etc. You don't have to remember this, just this is for your knowledge. Okay, now I will give you a couple of examples. The basic fundamental absolutely remains same. Okay, let's go one by one. One sample sign test, which is basically comparison with one sample t test. Okay, so now let me give you example. Price index value of 29 homes in a suburban area. Okay, is like this. So let me just share this one as well. Okay. Yeah, so let's get this file downloaded, meaning opened in your laptop till the time I'm explaining you the example. Okay, so price index of 29 homes in a suburban area in the northeast were determined. Real estate record indicate the population median is similar for similar homes with previous year is 115. Okay, and the test will determine if there is a sufficient evidence of judging the median price. Now, do you remember what is median? The median is, so Mr. Padmanabhan, there is a test called normality test. Okay, so the question is, how do you find out whether the data is normal distributed or non-normal? So there is something called normality test. This is also a hypothesis test where null hypothesis says the data is normal, alternate says the data is non-normal. Okay, and we feed the data in the software calculates the p-value. If the p-value of the normality test, okay, is greater than 0.05, then the data is normal. If it is less than 0.05, the data is non-normal. Okay, that is a test we do basically. All right. So if we find the data is non-normal, then we can go for these kinds of tests. Okay. Now, so median, everybody remembers what is median? Median is nothing but if I arrange the data in the ascending or descending order. Let's say for example, I have the data like 12, 15, 20, 30, 35. Okay, this is my data. So if I arrange it in a ascending order, so this is my central value. So 20 is the median in that case. Okay, the middle value of the data is the median, correct? So whenever, understand this is very important rule. Whenever you have normal data distribution, okay, normal data, we consider mean as the indicator of the central tendency. Okay, but whenever we have the skewed distribution like this, okay, then instead of mean, basically we consider median as the center point of the data. Are you clear, everybody, with this? Just give me yes in the chat box. Have you understood this differentiation? Just give me yes. Yeah, I'll share the file once again. Huh? Yeah. Now the file will only be seen if you have the Minitab software downloaded in your laptop. In mobile it will not open. In the laptop or desktop where you don't have Minitab, it will not open. Okay. Yes. All right. So what they have done is, if you open the file, let me also open. So basically 115 is what was the standard, and they want to see whether recently is there any increase in the rates of the homes. Okay, so let's say let's for our consideration 1 crore 15 lakh rupees. Okay, so 1 crore 15 lakh was the benchmark earlier. They want to see the median, has it shifted? Okay, is there a shift in the median now? Okay, so they have collected the data and they are basically so yeah, I'm just opening this file as well. Yeah, so they want to check whether this wow, super. So the data what we are basically checking is the price index data. Okay, so everybody just follow this. So you can just go to stat. In stats there is something called non-parametrics. Okay, in that you select one sample sign test. Stat, non-parametrics, one sample sign test. Okay, when the data is non-normal, generally we use it. So we are just learning that. Okay, go to stat. Let me also do this along with you. So go to stat, non-parametrics, one sample sign test. Okay, once you do that, the variable is price index. Okay, so select the C4 column called price index. Just double click on price index, it will get selected. The confidence interval is basically, let's keep it 95%. Actually they have said that you can set it at 90%. In the example they have said that, but if you keep it 95% also is okay. Then just click on test median, and here you have to write 115. Okay, and because they want to check whether the new one has what you can say, oops, the new one has basically is greater than. Okay, so now in this alternative, so it is called alternative hypothesis. It says less than, not equal to, or greater than. Now if you are not sure whether it is greater than or equal to, you can directly say not equal to, or right now you know that it is greater than 115. So just want to check whether it is statistically significant greater or not that statistically significant. So just select greater than and click on OK. Wow. So here you can see you have got the p-value which is 0.2291. Are you understanding? So similar kind of thing. So there are 29 total values. Now here you can see what is below 12 and above 17. Let's understand this. N is equal to, what is N? Type in the chat box. Yeah, Krish, go ahead. Please go ahead. Any kind of emergency, you can check the recording anytime later. Okay, emergencies first. Please go ahead. Yeah. What is N? N is equal to 29, meaning number of sample. If you see price index data, if you scroll down to the price index data, there are 29 data points in this. Okay, you can see here 29 data points, right? So price index data has got 29 data points. Clear? Yes, number of data points 29. Now there are few data points below 12. That means what? What is median? We say median meaning if I arrange all the data points, let's say from 0 to 500, whatever it is the last number, 510, whatever it is there, 115 is at the center. Okay, whatever is the median basically. Okay, so what they are saying, right now there are 12 data points below this value, meaning understand this, just let me. So if I arrange the value in the ascending order, below 115 there are 12 values are there, and above 115 there are 17 values are there. Are you understanding this? Just give me yes in the chat box. Clear? So the data has been arranged. So below 115 there are 12 values, and above 115 there are 17 values. Now what we are checking is this 12 and 17, number of 12 and 17, is this statistically significant difference? Okay, that is what. Now p value is 0.2291. Again, here what will be the null hypothesis and what will be the alternate hypothesis? So here what we are saying, median of the first what you can say below, and median I will say below, meaning the what you can say 115 below and median of 115 above is equal. Okay, and alternate will say median of below is not equal to median of above. Now mathematically there is a difference, 12 and 17, but is it statistically significant difference? Okay, the rhyming will remain same. What the rhyming says, p low null go, but right now the p is not below than 0.05, so we cannot reject null hypothesis. So we have to accept the null hypothesis, which says there is no statistical significant difference between the median of 115 and whatever is the current median. Are you clear with this? Just give me yes in the chat box. So the 12 and 17 is, there is a statistical, what is the mathematical difference, but it is not significant difference for a long term. That's what this p value is taking. Very good, superb. So on the other side we can say 115 median, okay, 115 median and 144 median. Is there a statistical significant difference between the two medians? So the answer is no. Clear? Are you understanding? Just give me yes in the chat box. So here we are comparing the medians to medians, because this is the test of the non-parametric test, which is when the data is a little non-normal. Clear with this? Just give me yes in the chat box, everybody. See, it is basic. If your foundation is clear, this is all equivalent. Okay, let me clear with you. One sample Wilcoxon sign rank test. Okay, for example, when we use, it is just like one sample z test. Whenever we have more than 30 data points, we use this test. Okay, example. Let's say achievement test score of in science recorded for 9 students. Perform the test to judge if there is sufficient evidence of population median being different than 77 using alpha at 0.05. Okay, so median is 77, median different than 77. That is what they want to check. So here in the same file, you have something called, just below that one sample sign test, there is one sample Wilcoxon test, and you have to select achievement data. Okay, you can see here in the data set there is something called achievement data, where the sample of the 7 students are there, got below 14, above 14, what is mean and p value. Okay, if I take 144 as median, now we are not calculating mean here. Okay, what we are saying here is because the data, we are considering the data is non-normal data. That's what we are saying. We are comparing the median of that. Okay, median of that has shifted significantly or not. Okay, so what it does, it just divided that into 2 parts. One is 12 and one is 17. And let's say, for example, if the median has shifted, one would be, let's say 12 and other would be 25 or 27. So there is a clear-cut median shift. Yeah. So in that case, they would see the mean wala is just the average, right? Average to average comparison. Here the mean is how many number of data points above and how many number of below. That is a number game. Okay, so that we need to remember. Yes. So now these tests basically, we don't use it regularly. Understand this. These are very, very seldomly used tests. Okay, but it is like, you know, when you are studying medical, very rare to rare case comes, then only we can use this. See, whenever the data is non-normal, that too the after transformation not getting transformed, then only we have to use this test. Okay, but because it is in the syllabus, we have to cover. But to be very honest with you, barring only one case in my 15 years of experience, I have not used this test. Okay, so don't worry even if you completely forget it, but remember, whenever the non-normal test comes, non-normal data comes, remember there is something called non-parametric test also we exist, and you can refer this. Clear everybody? So don't worry, don't pressurize yourself to remember everything. Okay, I'm just quickly, see, basic fundamental remains same. There we are testing, you know, mean to mean. Here we are testing median to median. That's it. P value is what we want to check, and we don't have to calculate it. Software calculates it for us. Okay, but we need to read this. Okay, and nowadays, for example, if you are not reading it all, you have the you know, your AI assistant with you. So just copy the data and put it in the data and ask AI to read it. That is the best strategy. Okay, nowadays we all are following. All right. Now let's follow this. Open this, and one sample Wilcoxon test we will do. Okay, and one more test I will do, and then we'll close this. Okay. So when so go to stat, non-parametrics, and one sample Wilcoxon. Just check out this stat, non-parametrics, and one sample Wilcoxon. Click on that and just select achievement data. Achievement is a C5 column. Okay, in the C5 column there is something called achievement. Just click on that. Now the test median is 77 and alternative hypothesis is not equal to 77. That means the data is not equal to 77 is our alternate hypothesis. Just click on OK, and the software is giving us p value 0.889, which is again, it is greater than 0.05. That means there is no statistical significant difference between the median and 77. Okay, so both are very, very close to each other. Clear with this? Estimated variance is 77.5. So 77.5 and 77, there is no much difference between these two. That's it. Okay, it is that simple. So the interpretation also is given. I'll give this document to you, just you can refer. Again, Mann-Whitney test also similar to two sample t test. Okay. Yes, Pramod ji, exam will be done, can be done on Sundays, on holies as well. Absolutely yes. We just have to share the exam file. Okay. All right. So this is what basically you know, I just want to complicate the things. Mann-Whitney test ke liye bhi I think we have some data. Let me just check if we have some data for Mann-Whitney test. Okay, there is something called MAT A and MAT B. Okay, let me check if we can do this. So you see MAT A and MAT B, there are two values, and we want to do the Mann-Whitney test, which is similar to two sample t test. Okay, so let's go to non-parametrics and Mann-Whitney just here. And the first sample is MAT A and second sample is MAT B, and just click on OK. Again, you can see here where is the p value here, significant at, yes, so here is the p value, which is 0.5967, which says you know, so 0.5967 is absolutely, again, there is no statistical significant difference between the medians to median. You can see here 10.750 and 11.250. There is not much statistical significant difference in the medians. Okay, I think you got the idea about non-parametric test basically. So it is a little extended version of the hypothesis testing, you know, of the non-normal data. Okay. Can you give some exam test papers for SSGB? Yes, we have that in the in your course curriculum itself. Let me share with you. Okay, any question you have, please let me know in the chat if you have any kind of question. Meanwhile, I'm just opening the course content just for your explanation. Tomorrow we have the yellow belt session. If you want to refer somebody, you can send them to the yellow belt. We will be putting the invitation in our this one, okay, communities as well. Okay, so you can just share that with your colleague, and if they also join our green belt black belt community, you can get some referral bonus out of it. Okay, now so I'm just sharing my screen. So this is the green belt course 1 for your reference. Now in the same okay, Pramodji, don't worry at all. It is open test. Okay, open book test. You can refer your notes. Okay, don't worry at all. Don't take any pressure. Okay. Now, so here is, if you scroll down, down after the, there are some sample here. You can see Lean Six Sigma Green Belt sample questionnaire. Okay, so here are the questionnaire, and below that there are answers also given. So first you go through the questionnaire, just check your confidence level, how comfortable are you giving the answers, and then you can check your answers below. Okay, so this is the Kiranji for you. All right, and then confidence level, please clarify. See, confidence level is Jitendra ji. What is confidence level? Let's try to understand the concept. Whenever I am making some product or anything, let's say I am a quality checker in a BPO call center. Now, to be very honest, I cannot check each and every call which basically I am having. So I will take some samples. Okay. Now, every time there are some sampling strategies which we follow. Every industry has their own norms of sampling strategy. Let's say one of the very thumb rule is square root of n. Let's say I'm having 100 calls every shift on an average. So I will check 10 calls every day. The square root of 100 is 10. So I will check 10 calls every day for the quality. Okay. Now, if I follow those strategies of samples from the industry standard, okay, I can be confident about the prediction, about the population, about the behavior of the population, about my inference of the population. Now that confidence basically is generally set at 95% because I cannot be 100% confident, because I'm just taking sample, right? So that is called confidence level, and we can set the confidence level at different level. Generally, they suggest set it at 95%. Don't, if your sample size is very high, let's say out of 100, I'm checking 50 calls. So my confidence will be very high. So every alternate call I'm checking, so I can be 99% sure. Okay. On the other side, let's say I cannot test 10 calls. I'm just testing only 5 calls out of 100. So my confidence will go down. So in that case, I can set my confidence at 80% or 90%. Okay. So that is called confidence level setting, which is basically go parallel with the sample size of your industry. Okay. That's how it is. And this confidence level basically is important to check our probability of making error, which is the p-value. P-value is nothing but probability of making alpha error. Okay, I'm not going into that detail because it will take another 1 hour to explain what is alpha error and beta error and what is p-value, etc. So p-value is, see, where your confidence is 95%, your probability of making error is 5%. That is called 0.05 p-value is all about. Okay. Clear? Just a brief explanation of it. Just give me yes if you have understood it. And in our masterclass archive, there are a lot of, just type confidence levels and confidence intervals. There are a lot of types, a lot of sessions I have taken on the same topic. So you can refer that as well, okay? Yeah. Give example 4th of March. Yes. Absolutely right. Pramodji, my all wishes are with you. And just go with the open mind. Don't worry about the result. Okay, just follow the process. And then if you, let's say, score less than 70%, you can re-exam. That's it. Nothing new, right? We will take the re-examination of it. Okay, TVS visit, fantastic. So last week, meaning just in this week itself, I was at TVS, as I said, Madurai. And they had their tire division. TVS Eurogrip is a very big brand of TVS. So it's a backward integration basically. TVS TV Sundarraman, basically they make the Yeah, it was fantastic. That's what I'm sharing the experience. And it was a backward integrated, so they started making small tires, the scooter tire first, and then they realized the same technology can be adopted. Now they have started making the big tires of the trucks and the tractors and the big earth movers. Okay, so this R&D and the quality team was there for the small tires and big tires. So there are a lot of people were there into that. Almost 18-20 people were there, and all are senior people, and they were doing DOE, by the way. Okay, some of them were doing DOE, some of them were qualified into Taguchis, etc. So a lot of next level things we discussed. Okay, so see, it depends on the audience basically. Now today there were a lot of new members in the room, and I had to start from basically the basics of hypothesis, etc. But if the audience is already the experienced audience, the matured audience in that particular topic, then we can start the level discussion on the different levels. So that was a very great experience for me as well. It was first time, and as I said earlier, my guru, Mr. N.C. Narayanan sir, is from from TVS. So he learned a lot of things from TVS. He taught it to us, and now there are a lot of trainers and consultants who are doing this. Okay, across the world, I would say, and I'm proud to be one of them. And I training back to the TVS group was a complete full circle. That's what I wrote in my experience in the community. Okay. So see, Girishji will cover all the tools which are there, which are required in the content. Apart from that, anything which you, for example, this now, you can make a list of the tools which you want to be covered. Okay, of course we go out of the curriculum and cover the topics as well. Okay, but it is not in the list. Okay, but definitely we will try to cover the tools which you are recommending. Okay? TVS Chennai Deming Award Factory, only company in India. Fantastic. Yes. Good. I think that recently Tata's also got the Deming Award. Let me check Tata Motors as well. My father worked in TV. Wow, fantastic. Great. So TVS is something, it's a very legacy company, almost 115-year-old. They started in 1911. Okay, so it's a very old company, very old legacy of that, and which can be seen ingrained the pride of it's an Indian company and grown very well now, diversified. It's a huge empire now, into 40 different industries, not even scooter manufacturing. Okay, but it was a great experience, and see, this is what See, right now the economy is shifting, economy is turning, twisting, lot of things are happening. So it is very high time for us to, go to the next level. Okay. They got Deming Award in Tata. Yes, Giriji. Thank you very much for confirmation. Very good. Superb. So I think that's it from my side. Now we have posted one requirement of one of the Vadodara based client. Okay. If you are fitting into that, it is a 6 months assignment kind of a thing where you will be stationed there. If you are fitting into that, please share your CV, with us. And again, if you are not working, because if you are working, then this is not for you. Okay. If you are looking for a consulting assignment, if you are looking yourself to transit to a consulting assignment, or looking for a job switch and you have some time with you, then only you can jump into that. Okay, I will not encourage you to quit your job and do this assignment. All right, so that's my recommendation. Okay, thank you very much for joining. Tomorrow send your colleagues and friends to the yellow belt session for for them also to enroll into this. Right, thank you very much for joining. Keep learning, keep growing. This is Dinesh Patil signing off. Till the time, bye, take care, good night.